Hello everybody, welcome back to another video. I'm hoping you guys are all having a fantastic day. So as you can tell by the title, we will be talking about this very large winter storm potential across the northeastern United States. This thing is extremely complex. There have been pretty large changes. A lot of new information and data has been processed, and this is why I'm uploading this video a bit later than I would like, because I wanted to wait for all the models to come in with their data so I could finally kind of accumulate it into the most accurate forecast I guess I could give from the current time frame. And let me tell you that this thing will definitely still change. There are big updates that will happen. It's just a matter of, how will those updates kind of unfold and what impacts will they have. So yes, this thing is a dynamic system. You've probably heard all about it on the news and whatnot, and for good reasons. If this were to occur, as some of the models show it, this thing could be a historic system for many reasons. So before we get into this, I do want to say thank you so much for clicking on this video and watching. Obviously we're at the beginning still, but I am a weather enthusiast, a weather hobbyist. I do not give out official forecasts. For that, I always go to the National Weather Service, but I just kind of like talking about the weather, and people seem to like listening, so it's a win-win. I would probably do these videos regardless if no one paid attention. This is just what I like to do, and it's very fun and entertaining, so if you like this type of stuff, check out the video, watch the other videos on this channel, and if you do, you could subscribe and like. I'm not forcing you to do that. I just say this at the beginning because at the end I get too carried away and I forget. Alright, let's start talking about this. Oh, also, I answer most comments, so if you have a comment, leave it down below. Alright, let's start talking about this. So, first off, I want to show you what the National Weather Service Weather Ready Nation map is. If you don't know what that is, and that just sounded like a bunch of weird words, it's basically a map of the United States. And this is obviously the U.S. government that forecasts, or has an agency that forecasts and gives out advisories, warnings, and whatnot for the United States. And the thing is that this usually is just for imminent threats, right? Advisories, warnings, and you can see that right now there isn't anything in particular that is super alarming. We do have a bit of snow and actually some freezing fog across Texas, right? But notice that this winter storm that we're talking about, there are just a few counties under winter storm watches. And the main reason for this is, and why I'm saying this is, because we're still far away from this, relatively. We are right now Wednesday evening. You can see this is still pretty far ahead of schedule. They're issuing this winter storm watch across the Boston and Rhode Island areas. And this will be occurring, if it does, late Friday and into Saturday. And that, through the day of Saturday, that's where things will be the worst. I'm showing you right now what the National Weather Service currently thinks where the heaviest snow will fall and how much of it. I'm trying to, let's see if I could scroll down a bit. So this is a bit, okay, whatever. I mean, you see the full image anyways. Notice that we, according to the National Weather Service, which this is updated every single hour, they currently think, and again, usually if it's past 60 hours, they just show like smaller amounts, and if they have higher confidence and a forecast plans out, they increase the snowfall amounts to what the models show, within the 24 to 30 hour time frame. So this is a pretty large amount of snow pretty far out, and you can see well over a foot across the eastern seaboard into portions of Delaware, New Jersey, New York, almost 6 inches, Boston, the Cape Cod areas could get even over a foot and a half, and this is just through late Saturday, so Maine here isn't even really maybe a fourth of their way through with this system, and they only give out the forecast of 72 hours. So this is official thinking so far, and again, this is extremely preliminary. Now, let's go forward and look at some of the weather models, because this is where things get really complex and honestly very, very tricky. So let's play this forward. So you may be thinking, why is this system so strong? Well, there are a few reasons as to why this system is kind of in such a favorable environment of development, and really the main reason is we have a lot of moisture towards the south. This thing is really untapped, and there's a lot of it. You can see it's just kind of floating around, producing little thunderstorms and rain, and it's basically just waiting for a system to come along and scoop it all up, and it does that in a big way, this system. Notice we have a lot of cold air to the north. This thing is quick, and this is actually a deciding factor in how far east or west this system may be able to kind of go, because this is an extremely powerful force, and if this goes a bit too early, a bit too quickly, the system might get pushed off even further east than we're seeing right now, and vice versa. It might trend towards the west if this is much weaker. But notice that what we see is this high pressure starting to develop again. It depends that the strength of that high pressure and how far this trough reaches. Notice that with current thinking, This thing goes from almost nothing on a radar, just a few little blips, to a organized beast, a snow machine, a snow hurricane. That's what I saw some people call it. And honestly, even though it's a pretty weird way of putting it, this storm is decently, or I guess, comparable to a hurricane in the winter. It's a monster, guys. And do note that across the mid-Atlantic, we start seeing snow late Friday. So again, this is preliminary. This forecast may change many times, and it probably will. So I just want to show that right now, the GFS does show snow across West Virginia, North Carolina as of very late Friday. So at least that's a good thing. That regardless of what happens, this thing will be occurring on the weekend. So the impacts will be lessened naturally because of that. Now, here is where the first kind of big deviance between the models is. Some models show this system not really as amplified and going towards the north. It shows it a bit weaker for an extended period of time. And what that does is it basically doesn't have the strength to kind of push along this jet stream. It just kind of goes along it. So what that means is it takes a track a bit further off the coast, right? And what that means is, well, the snow's still going to be falling across these locations, except it's not too heavy. It's a moderate snow, still plowable for many of these locations. But at this current time, 6 a.m. Saturday, it is still a relatively strong but pretty far off the coast nor'easter. Now, notice that by Saturday at 12 p.m. So this is, again, 1 p.m. for all the people on the East Coast because this is a Central Standard Time. This is already a very large system. It's pretty much a monster at this point. It very quickly intensifies from being a very weak 1,000 millibar low pressure to being extremely strong and saturated with moisture. Now, you can see that this fetch of snow is absolutely impressive. However, cities like New York City, you're just on the cusp of this. And the thing is that the GFS model is the most furthest east model. So if you think this is what will happen, may or may not, because this is not the current thinking. I'm just going to show you many scenarios, and this is just one of many, so bear with me here. And that's what I mean. If you were to just watch a few minutes of this video and stop right here, you'll be like, oh, New York City won't get anything. Where again, there's a reason why the National Weather Service, despite the GFS being like that, still shows decent amounts pretty far inland. So this is just the current thinking. Notice that it does start taking a little bit of an arch, right? It starts strengthening, finally pushing up against that jet stream. Very heavy snow, extremely strong winds. This thing, regardless if New York City does get a lot of snow or doesn't, and I keep choosing New York City because it's just the biggest city that comes to mind in this area, but obviously other areas like Trenton, Atlantic City, even Washington, D.C., where you'll be seeing very fierce winds. Maine, especially obviously closer to the coast. Now, look at this. So, really the difference between this and this right here is that it obviously strengthens into a monster. So 956 millibars. Goodness, guys, that is a absolute whopping beast. But do note that is just really far off the coast in order to keep many of these cities from these extremely heavy snow bands. So my point is that if this thing were to shift, or really just maybe 50 to 100 miles, not even, into that sweet spot area, the axis of sweet spot, really, then this snow band would probably be, extending further into as far as these areas, and the coastal areas would get slammed. So it's just a little tiny of a difference, a little tiny of a little track deviation, and this thing is, this thing is going to be a lot more impactful, according to the GFS. So, this is the thing with nor'easters and why they are so hard to forecast. Because a system, like if this were to occur across the central United States, which 956 across land is very hard to get, but let's say it would, then, if it shifts through the east, even by like 200 miles, it's still an impactful storm. It's just further towards the east and for different people. In this case scenario, if this thing shifts off even another 100 miles in the next, several days, then this thing's really just gonna really dwindle with its impacts, and the storm still will be there, but a lot of people will be left, wow, so they were inaccurate. And to a sense, yes, with the track we would be wrong, the forecasters, but the storm is most likely still going to be there. And that's what I'm saying, that even with the GFS, if it were to be right and completely takes us off, I said this yesterday, it's a guarantee almost that this system is occurring. It's just a matter of how impactful it will be for the United States and really Canada. Do note that this thing, obviously 956 millibars by late Saturday, it continues shifting towards the north, extremely strong winds, just almost like a winter hurricane. I mean, truly very impressive. And then this thing finally skedaddles out of here. So Again, and that's pretty consistent with the timing. That's by noon Saturday, even a bit later, will be pretty much gone and out. So yes, you can see that the snowfall is extremely limited to the land with a scenario like the GFS, and many of these areas just pick up a few inches. And again, if I were to show you the land or the water snow, which this model or this website doesn't show this, you would see amounts, well over 2 feet probably here, if not 3 feet, which is where that center of that storm kind of was. So again, guys, this is still, while the trend has been a bit towards the east, it's not significant enough to be, I guess, kind of disregarding this situation as a much less significant storm. I would say that the chances are still as good as yesterday. And let me show you some of the other models, because if you were to just take a look at the GFS, you'd ignore it. But let's take a look at some other models and show you what may be the result. So Canadian, this last one came out at noon. Let's see what it shows. Now, do note, we do have the same features. We have a ton of moisture across the south. We have a ton of cold air towards the north. So the ingredients are there. And notice that by late Friday, this thing is snowing. We're across Virginia, West Virginia. Again, these areas, right, this pales in comparison to what the system does later on. But you'll still pick up a few decent inches, right? So definitely don't disregard that just because you're not seeing. Sometimes that happens where I guess it's kind of like the strong snowstorm fallacy. I don't know what to really call it. But, if you have amounts across the Northeast that are 20 inches and then amounts, like 5 to 8 really seem small. But 5 to 8 inch amount is a 5 to 8 inch amount. It doesn't change. It's just a perspective of it when it's compared to these giant snowfall totals. So I do want to warn against that. Canadian, notice that compared to yesterday, let's take a look back at this. I could directly compare it. Here, come on, let's go. It's a bit further towards the east, actually, by quite a bit. So it also trended a bit away towards the coast, or away from the coast. Still brings in a decent amount of snow into the Northeast, New England, right, Connecticut, Rhode Island, Massachusetts, and Maine. And it doesn't get as strong as the GFS. Still a whopping system at 977 millibars. An extremely impressive storm, except it just really skims the Northeast. It's still surprisingly a little bit more snow than what the GFS shows. Total snowfall, you could see, there we go. This model actually does show the snow that falls on the land, and it shows a lot of snow. It's just the heaviest amounts of it are off the coast. And again, if it were to be the the GFS model, it shows a stronger system, so those amounts are much higher. And all you need is just 200, 100 miles further west, which really could occur very easily and very quickly with just a small change in a forecast. And then this thing shifts. And it would be hard enough to track this if this thing was already formed. But this thing is just going to be forming right here and exploding into a system. So anything prior to that could shift it. And that could include the northern wave of the system changing, the phasing of them, of those two being a bit off, a bit early, a bit weaker, a bit stronger. It's very complex. So regardless, the models are doing a very, very good job. And this is why it's still, just such a tough scenario to predict. Now, if you were to take a look at model like the NAM, let me show you. So this is 84-hour snowfall. It only goes out to 84 hours. This is what the this is what it showed yesterday at midnight. You could see it still wasn't showing the upper half of it because it got stuck at 84 hours. You could see it showed quite a bit across North Carolina. Today, 6 o'clock in the morning, with this model run, this is what it showed. Okay, so it started to show that system. Today at noon, you could see it showed a pretty significant beast. But then look, this is what's kind of shocking. With the afternoon run, there's nothing. And you'd be like, what happened? This system, according to the NAM, it just completely goes off the coast. And that's the most aggressive scenario from all the models we've seen. And again, the NAM, I would say, is a decent model, but, just because of how far it's jumping around with this scenario, I just don't think it's doesn't have a good handle of this. But yeah, I mean, look at that. That thing is, if this were to occur, it's just really Cape Cod and maybe portions of Maine seeing some pretty good, decent snow, and then everywhere else just extreme winds. But and then it's gone, and then that's it. So, I don't think a scenario like this is likely, and I looked at the National Weather Service, and they said that as well. It's not likely, but something we'll have to watch for, if these models continue. And obviously, a trend towards the east doesn't mean that it'll just continue going towards the east. It could start shifting back towards the west, or it could just kind of shift towards the east, but maybe orient the formation of the system a bit differently, causing or higher or lower snowfall amounts. And I want to take a look at the model called the European model. I'm sure you know what that is. That's the one I haven't showed you yet. Again, another perspective from this system. And the reason I'm showing you this is because this is a 90-hour model. or this current one. So basically what you have to know is that the European comes out twice a day, but it also comes out 2 other times in a day, but only out to 90 hours. And for short-term systems, that's great because we don't have to wait 12 hours till the next update. We could, just wait a few hours, and we have our little update. So let's see what the European most recent data shows. You could see it shows a little bit of lake effect off the lakes. Again, nothing really significant, but then the system out of nowhere appears, and boom, right there. So this is what the most recent model of the European shows, and you could see that the European is a completely different story compared to the NAM model. If you recall, the NAM was the one that just took it off the coast, and this is the one at 18Z. So why am I showing you this? This is very important because if you were to take a look at the noon one, you could see this is what it showed. Let's not look at that second one, but let's take a look at this one. This is what it showed from that storm, right? Again, the main operational European model. And if you recall that most of the models, including the GFS and Canadian and that 18Z forecast, have shifted off the coast, but the European really hasn't. And this is why it's such a hard forecast, and it's too early to call what exactly will happen. Look, I mean, it maybe shifted a bit towards the east across some of these areas, across New Jersey and whatnot, but the eastward shift hasn't been as significant. Compared to the GFS. So we'll just have to wait and see because at this point, this is just the battle of the models. I mean, truly, that's literally what it is. The European ensembles, let me show you, EPS members. These are 50 models combined to show us what they can, what they think the system is going to do. Now you may be looking or wondering, okay, you just showed us 2 models. Why are you showing us 50 all of a sudden? Basically, these 50 are grouped in a family called the European family, and what am I trying to do? I'm trying to click on total snowfall, and I can't seem to locate it here. And basically, sorry about that. I look at this, or forecasters look at these ensembles to show, to see if there's any shift in the forecast. So there's a bunch of them, and they're averaged out. The mean of them is to create this image, and then basically, if the forecast track shifts towards the east, that means the models are generally agreeing that it's a forecast. It's probably trending towards the east. So let me just stop speaking because that might be confusing you a lot of you, and I'm a bit distracted here. But notice this is what all the ensembles showed yesterday at the noon on average, and you can see it was a pretty hard-hitting storm. Again, these are the European ensembles. This is what the ensembles showed at midnight. Again, a pretty hard-hitting storm, very minimal changes. While the GFS at this point ensembles were shifting pretty radically off towards the east. So, we haven't, and then this is what the European ensembles showed today at noon. So still, a very significant system, maybe just a bit further towards the east, but really not anything too awfully significant, and the strength of it is still very strong. So this is an extremely hard forecast because the GFS models, while the European models are more consistent, the GFS, which is another family that is also very accurate, very good, and forecasters look at it, they've been shifting it aggressively towards the east, while the European ensembles just kind of been they've been just more consistent. So which one's right? We don't really know the answer to this. This was yesterday at midnight. You could see already a much weaker storm. This was today at 6. Again, further kind of continuing that trend of eastward shift. And then again, today at noon, it was even more further towards the east. And then today at the 18Z, the most furthest east scenario out of all of them, just clipping the northeast. So, these are just astounding changes. If the European ensembles, for example, the mean started shifting along with the GFS, that would make more sense because that means that they're following a trend together. But they're not. The European models are pretty fixed, and the GFS are fixed. And this isn't too far out. I mean, this is less than 84 hours. I mean, take a look at the NAM even itself. Such an abrupt change between the snowfall between the evening model run, which shows really just not even a system affecting the United States, and the 12Z, which shows a monster. So, folks, this is something that's unprecedented and unfortunately adds to the confusion of everything, but we'll just have to wait and see. And I know I hate vagueness, but that's really the truth of this. Icon model, you can see the German model also shows a trend, pretty drastic one towards the east. This is the one at evening today, the most recent model run, and this is today the one at noon. You can see it was further towards the west. Today in the morning, it was a bit further towards the east, so you can see this one has been jumping back and forth for a bit longer now. But with I think what I showed you yesterday was this scenario, and you can see the icon, the German one, has actually been more consistent with this being off the coast comparable to what the GFS show. So you can see there's different variations to this. The Europeans have been consistently showing, the European models have been showing consistent heavy snow across the Northeast. GFS have been consistently trending eastward, and the German one has been consistently showing a eastern scenario, but it hasn't shifted really further off the coast compared to what it did yesterday. So very different aspects of this. And again, for National Weather Service, this is a nightmare. But you saw some of those GFS ensembles almost completely missing the United States, right, with that snowfall, like the NAM and the GEFS averaged out. But that's why, this thing is a nightmare. But if you were to take a look at the National Weather Service official snowfall forecast for as of currently, you can still see that they're definitely leaning towards more of a European scenario, which again I think is more probable, but it's still very hard to tell. And I think I did show you the European model itself and its snowfall, but I didn't play it out for you. And I want to show you quickly how different it was from the other models in terms of its acting. Nope, I don't want to click on snowfall. I want to click on precip type and rate, or just precipitation type. So again, there is our system, our cold, our warm air towards the south. Obviously, very, very potent storm potential, and you can see that the Europeans start showing this much further towards the land already, this development. And again, all this makes a giant difference. Overall, the models are in pretty good agreement, and if this were a system on land, this would not be as much of a nightmare forecast because of how it still would be an impactful nightmare, I guess, regardless of whether or not it's 50 or 100 miles this or that way. In this case, that could mean all the difference. And look, there's that system. A lot of heavier snow getting further inland. This thing's starting to amplify, reaching insane amounts of snow into, say, Boston, Cape Cod, Maine, and extreme winds, and then it pulls away, obviously leaving a lot more snow compared to the other models. So yeah, that's basically it for now. There have been a few eastward shifts, but it's still too early to call anything, and we'll just have to keep an eye on this. All right, guys, thank you so much for watching. See ya. Bye.